Oh,
Okay. Uh, could you join the stream and see if it's working or how well it's working, or is it not live yet?
Gabe, run that live. Oh.
Testing, testing. Audio, audio, audio.
You look a bit like a caveman with that hair, honestly. It's
Thank you.
getting kind of ridiculous now.
Let's go. Beast mold. But
Yeah, it
can
seems
you
to
hear me?
work.
Can you
Yeah,
hear
I
me
see
fine?
everything.
How about keyboard noise bad?
Hmm.
Doctor okay. Sound okay. Someone's already in. Based. Video okay, thank you. So we are going to be doing, we're going to be starting at 12. My brain is slow, but I should be able to switch over to seeing. Oh, what the heck? Can I not minimize OBS without minimizing the. No, that would be cringe. Oh, for Christmas sake. This is why we're working these things out right now. You know what? I can put it down here. That works. I'm I'm great at this, honestly. So we're gonna work on Daxa. I'm gonna be trying to think of what to say. Patrick, what do we have to do? Oh, do you want to start a live share so we can?
Yeah, sure.
All
I
right.
would probably work on the task graph sample because we probably can't execute for a while.
You will, or I
Anyway,
should.
no, I'll start the live share.
Oh, will you do the sample, or or is that what you want me to do? The task graph sample.
Uh, yeah, but also implementation. The implementation is gonna be pretty big.
I see. All right. I'm gonna hop into your workspace. Uh, okay,
Second.
we're all set there.
Did you ping the people already?
I, I guess I should now. Yeah, let's do that.
Phantom is my older brother. Oh, Jaden's older brother joined?
Mm-hmm.
Damn. Getting into graphics programming. He's learning C++. C actually, and rated. Oops. Done it, it's on here! Ooh.
Yeah,
I
Jan
mean,
just joined. The German infiltration is real.
German, yeah, we'll take over, honestly. I'll just switch to speaking German and he'll be left alone.
All right. So let me take a look at this sample that you have started making. task list sample. Looks like you copied the hello triangle. Let me rename these. Task list. All right, looks good to me. We have this timeline semaphore that we wait on, but the timeline semaphore is never set.
Yep.
Okay. Oh, you're working up here?
I'm
You're
thinking.
creating the task list.
Yeah, task list. Yes, we need a task list present info. So pretty much the same as the normal present info, with the difference that you take a task image or task image view instead of normal image ID or image view ID. That's an add present.
Okay. ID fetch can be omitted. It's known ahead of time. Vertex buffer equals interface get buffer. Task interface device create buffer. For the staging, and then we upload to.
I'm looking at the stream right now. Is the view count delayed because there are already 1, 2, 3, 4, 5, 6 different people that said hello in the chat? Ah, yeah, I think it's kind of delayed for some reason. That's interesting.
Maybe, I don't know. It says there's 5 viewers right now.
Yep. Yet now it's 6. Yeah, it's catching up slowly. Strange.
Hey guys. Welcome, Lion. Okay. So when we add this task, Patrick, where does it go, and what do we do with it? We're able to queue it, right? So what? Like that's how it's supposed to work. So what happens? Do we retrieve a task when we say add task? Do we get it as a return value or what?
Retrieve a task.
How do we queue it in the future?
The task list is the recording of what you want to do. So it will, when you say add task list, it will just add the task you pass into that current recording. So you don't get anything back. It won't return anything.
Okay, so then so we recorded it, but then how do we queue it? How do we submit it, I guess?
There's a compile function which is called at the bottom, which goes over the graph and generates all the synchronization. And then in the draw function, we say task list.execute. I'm not sure if it takes any parameters.
Oh, so specifically, this is the task list that we are creating, and then we can queue it as itself later.
Yes.
So then, if we wanted something that would happen only once, we would put it in a separate task list that gets queued separately.
Yeah, for example, or you just do it manually, of course. Like, the idea is that the task list basically is captures the whole control flow of your whole thing, of your whole program, pretty much, your whole renderer. Except, of course, for like tinier things that don't happen regularly. So, for example, if you like upload images or texture streaming, or I guess later serialization of chunks and stuff that won't be in the task list. Maybe that will be a task, but for now there won't be any conditionals in the task list. Maybe that will probably come later. I've not thought about that, if that even makes sense at all.
Okay.
But yeah, that's the current idea. You put everything in the task list, and when you have like special stuff, you usually put it into a task where you do everything manually in that task. And I mean, the API currently is super simple and very bare bones intentionally, so we can see what usage you have and then implement helpers for that. For example, like it, I don't have any good examples right now, but I mean we will see the use and then we can implement helper functions and stuff.
Mm-hmm. That makes sense to me.
Yeah. For example, I already have such a task in the example, because we don't have an image uploading any uploading API or downloading API. I literally just make a task where I say that I write to the vertex buffer, and then I create a temporary staging buffer, map memory to it, write the memory, and then defer the destruction, and give a manual copy command. Technically, we probably need a pipeline barrier in between here. I'm not too sure about that. I don't think we need one. I think it's fine like this. But yeah, this is pretty much just like manual. I guess when we have a file uploading API, not file uploading API, any uploading API, then this would be easier. And I guess uploading is pretty much the thing that we have to do regularly. So probably not Daxa 1.0, but we should probably make a utils library with a linear staging allocator buffer and stuff.
Right.
Yeah, but that's all the after 1.0. Task list will be crazy to put in anyways right now.
Yep.
Okay, but we're gonna try that anyways.
So do you think there's much I can do to help you with task list specifically, or should I work on something else?
No, task list is you can help me.
Okay.
Specifically, I have some design questions I don't have fully figured out, I guess.
Okay.
So first of all, for now, we won't have any reordering. That means the tasks will all be executed in the order that you recorded them, even though it may be inefficient. Like later, I'll probably enhance it to be able to reorder tasks to be more efficient and even use like asynchronous compute automatically. But that's very complicated. So for now, we'll just first of all we need a list of recording, like a vector of variance or something.
Okay.
I guess the index to this vector is also like the task ID. Do we need a task ID?
Well, should we give the ability to, like if you have multiple task lists, you can queue the same task in multiple lists by using its ID?
Nah.
Because if we wanted to do that,
you can.
We would have to have some sort of create task, as opposed to adding it to the list or getting it from the return.
So you can see that when you submit a task, it's already like in a struct. This is like a task info, I believe.
Okay.
They called it. Yeah. You can just store the task info and submit it.
I see. Okay.
Yeah. Yeah. Also, this is like kind of temporary, I guess. So all this content inside a task should really be like your renderer's functions. So like renderer. And then you give it all the attachments. So.
Oh, so you extract the info from the task interface and then.
Yeah, and then put it in. And the idea behind this is that your renderer stays completely agnostic. It doesn't even know task lists exist, right? Yep. So in the case that I drastically change the API, all your rendering code will be safe.
Right. You also just need the little glue in between.
Exactly. Also, this makes it very clear when you like reuse stuff and everything. Yeah. And I guess this glue is kind of ugly, but I've not seen an
No, I think it's
implementation that gets rid
convenient.
of the glue. Yeah, it's definitely convenient. It's like more lines of code, I guess, but I've not seen an implementation that could get rid of that actually. So yeah, whatever. Doesn't really matter. But yeah, for this sample, we can just inline everything into the
right.
Lambda here.
So here we create a staging buffer, upload, we map the memory, upload it, and then copy it over to our actual permanent buffer. And then we have a render task that draws that buffer, command list push constant, and then that buffer is referenced in the shader here. So we have a buffer ID in our push constant, and we get that buffer ID and we index it here. Sorry, we index the buffer here, and then we extract that information into our what in OpenGL would be called varyings. I don't actually know what these should be called. The data that gets transferred from one pipeline stage to another. So we put it into this vertex output here, or sorry, here, and then consume it in the fragment shader, which all we need is the color. Let's see why it's confused.
Oh, swap chain image. I'm stupid. Whoopsie doopsie. Yeah, so I mean, because we are fully bindless, we don't need to do this, but I guess we should do it because it's like what you should do in like a proper implementation of the tasks.
This is very suspicious, Patrick.
Because I
image ID named vertex buffer.
Oh, what the fuck? My digestion takes all the energy out of my brain.
So now, do we have this vertex buffer anywhere?
Oh, I'm stupid. We actually need. Oh my god.
Okay, this makes more sense to me now.
Yeah, this makes sense.
Task interface get buffer is fine.
So, but again, because we're technically fully bindless, you don't need this because it's captured anyways. But yeah, just for cleanliness right now.
Right.
Okay.
Damn, it looks like the stream is delayed by like 30 seconds at least.
Yeah.
What were you gonna say?
Also, I've not thought about the implementation really, so the backend. I'm thinking about that right now. For now, one thing we have to do is record. Obviously, like save the tasks, right? The task infos. So that's probably the first thing we have to do. Is it generic already? I guess it's not actually. Yeah, we need a variant.
Of? Link. Say add task and task info. What is task info?
Pretty much a task, I guess.
Kidding. Wow, this is really complicated. Task info has resources and a task. Maybe I should zoom in a little bit just for clarity. So the callback is just a function, and the resources is a vector of buffers and images and image views. Sorry, buffers, images, and image views. I don't see variant, it's either task info or task render info.
Carbon already has 11K stars on GitHub.
For real? Wow.
Yeah, what the fuck? He's so gonna switch to Carbon in 20 years. Okay. Actually implementing stuff. So add task, we'll just queue it, I guess. We need to get the implementation. I just noticed we copied the tasks. Maybe we should move them in. Who cares? Performance won't be great, I guess, but who cares? It's also, like, it's only recorded once, right? So the internal representation and the execution is way more important than the recording.
Sorry, just looking at a couple things. So what other kinds of infos will we have? We have task buffer, image view info, and task render pass, task render info. Should these all be in the task variant?
We keep this whole thing. Just the full task render info.
The full task render info. Has a render pass begin info, attachment info. Okay, but what about these image view, image info, and task buffer info? Should these be a part of the task variant?
Oh, sorry. Yeah, this prefix is only to denote that it's part of the task list.
Okay.
Like, this is not really a task. This is just they're task images because they're like faked images for the recording. Because at the recording, obviously, like, you don't know what the image is gonna be yet. So we have fake handles for recording.
Right. So that's basically the create info for the handle.
Yep. Yeah. Exactly.
Okay.
Yeah, and currently you can only provide a callback because that's the simplest thing I could think of. Okay, so we just need to record the list right now. Also, you could go ahead and make like a proper add present function that takes in task present info while I write the recording functions. Usually there are only two.
I guess I need to know what present needs to do. So let me look at the hello triangle sample just to refresh my memory.
Oh, I was always also thinking, like, nearly all implementations have these fake handles to be a generic thing, so like no type safety. So instead of having task image, task buffer, and whatever, you only have task resource. I mean, one of the benefits would be that the implementation gets simpler in parts, I believe. But on the other hand, like, not having type safety is kind of shit.
So what does the command list submission? Does that happen when, I mean, obviously it happens when we,
yeah, it's so either you put in intermediate submits yourself, which there's no API for that yet, or you simply call present. Present
will submit?
yeah. Also, when you just end the command list and you didn't call present yet or anything, so you either have to call present or you don't do anything, and we'll just check if there are still command lists active that weren't submitted, and then we'll make a submit in the end. So if you don't want intermediate submits, you don't have to submit anything. It will just synchronize them for you and insert them for you in the end.
So for submission, we signal a semaphore so that the present can wait on it. If we have the ability to allow the user to do submission themselves.
Yeah, so we can obviously insert our own synchronization after, but yeah.
It kind of seems like the submission should be done by the the task list. Because we created the task and we say,
yeah, I guess, yeah,
we say execute. That's basically saying execute, to me at least, sounds like submit.
Not really. You can have intermediate submits.
Right.
Because you only have one task list usually. That's the idea. Just bring weird. Okay.
Oh, that's so iffy.
P. Oh.
Present takes a swap chain. We pass add present the image. Do you mean to actually use the swap chain itself?
We also need to pass an image. We need both.
Why is that? We specify the image in the, like, we handle the image in the task itself. What references the image that the present needs to do?
Then I send a sentence.
You don't so like present, what does present do that needs the image specifically?
Doesn't command list present take an image and a swap chain?
There is no command list present. It's device present frame.
Oh yeah, whoops.
And it just takes a swap chain.
Really?
Mm-hmm.
Huh. Yeah, then it only needs a swap chain.
Okay. So in this instance, do you think it should just take the swap chain? We don't have any abstraction over what a like task swap chain is, like the task kind of handle, or do we need that as well for the swap chain specifically?
Sorry, what?
So because we are using the swap chain here in the task present info, or we will be, um, do we need a swap chain resource for the task list, or do we just provide the swap chain as is?
Yeah, we can just take the swap chain as is, I'd say.
Okay.
Also, maybe we don't even provide it there. Maybe on the task list creation we provide the swap chain. So internally, when you have the
So when you
like
say present, it just does it.
yeah,
Can
I
you
think
have
that's better.
multiple swap chains, or should?
I guess you can't. Mm,
And that's per task list though. So a task list has its own swap chain, basically.
does that make sense though? I guess.
Doesn't seem
It's like
restrictive to
makes
me.
sense. Yeah, I think that's fine.
Okay, so then uh, add present does not need any info then, it seems like, unless we, or until we add the ability to signal our external semaphores, which is kind of weird. What have I done? Did I already remove it? These special needs. Patrick doing initialization within the constructor. Evil creature. Oh, sorry. I had OBS minimized, so I didn't see the chat. Daxa 1.0, we're hoping to have finished this weekend.
White. uh,
Message redacted. What? Or retracted? Hmm. Um, so we specify the swap chain in the task list creation. This probably should be optional. The swap chain, I mean. So I will make it so. And this should be, I mean, a swap chain holds a, is a shared pointer. So it will ref count. I guess that makes sense. Got to think about these things. And then what we can say is when we say task list add present, we can check the info as to whether or not that optional was filled because it needs to be. And also on compilation, I guess. Maybe check if there was no present in our task if we did provide the swap chain. But let's take a look at this add present implementation. It'll be in here.
We have a C++ initialization problem. Be fine.
Based. Fail string. You mean assert true M?
What the fuck? Yes.
There we go. Looking good. Whoops. Why is it mad? Class shared pointer void has kind of had kind of remember compiled. Oh, it still thinks that impl is this impl and not this. Sus.
But that's just yeah. I think it's
Yeah,
just delayed.
no.
I think it really.
Yeah, it'll fix soon. Maybe I need to save. That fixed it. I love these debug asserts, Patrick.
I think we can assert that in construction.
Wait, no, but a task list doesn't necessarily present. Right?
Yeah, but then don't. Yeah, I guess. Okay, yeah, that's fine.
This is some crazy code, Patrick. Convert attachment. Wow. How confident are you that we can get this into Daxa 1.0?
Not at all.
Not at all.
It's very dependent on how fast I can figure out the backend.
I'm just looking at this code and
Because
it's
I mean,
confusing
technically,
to me.
execute will be extremely simple. Execute will just go over the task again and call the task function
Yeah,
every
call
time.
the lambdas.
Yeah. The only thing that's complicated is inserting the synchronization.
Mm-hmm.
So we need to make like a graph of dependencies and then insert it. So it's like two passes. One pass finding dependencies, and then second pass inserting optimal synchronization. So I'm making two functions right now. Analyze dependencies and insert synchronization.
Interf. Amazing. So basically, what we're doing, I'm just explaining to the audience, Patrick. or at least, so what I'm doing right now is I am adding a task to the task list that is basically syntactic sugar around submitting and presenting your command list. Um, so uh, from the user standpoint, all they have to do is say add present, and then in the implementation, what happens is a task gets created when you say add present that does those specific device commands in order to get that presentation done. Um, and so I was just about to ask Patrick.
Oh, I think we need inheritance, by the way. I need some dynamic dispatch. I want some dynamic dispatch.
For
analyzing the graph. But because, for example, we have different task infos, and I want to get only certain parts that are guaranteed to be there. For example, resources or the callback. And I'm gonna make a task info, and everyone else is gonna inherit that. Can I? Oh yeah, that's enough, I think, already. Can but how do variants deal with inheritance? Do they at all?
What do you mean?
Could I say give me this base class pointer, and then it will check if the thing that's currently stored is inherited from that base class, and then give me a base class pointer. Because I still want the in-place construction of the variant and not allocate on the heap for every task.
Why are we doing base class? Why not just variant? I don't understand I don't really understand.
If I do variant, I have to make for every possible one an if else.
Okay, so then if you have inheritance to not do that in dynamic dispatch, there's no purpose in having a variant.
Oh, yeah, there's a purpose because we still have the better data locality because they are stored in unions in one vector. With normal inheritance, you just you'd allocate every single one on the heap.
Oh, is he?
But I just remembered that you have std visit, which takes a template, and in the template, I can do template magic and ask if this type I get from the template is inherited. So horrible C++ garbage, but it will work. Is it dot visit? Is it std visit?
Yeah, it's standard visit.
Okay. I already forgot.
And then it takes a callback and then the args. Wait, the first object is the callable. Sorry, the first argument.
Yeah, true. That's always confusing me. That was I use variants to shit in my UI library.
Okay. So, do we have any idea about the device? Because the device is the thing that does the presenting and the submission.
Sorry again. Oh yeah, we have the device. Yep. And construction, we need the device. Because if you see, look at the task interface, it will. I don't know if it already has that, but the task interface should have a reference to a device.
It does. Yep.
Is it its base class off? It's base off, yes. Base derived.
Patrick, Spewing out object-oriented code like a beast.
Look at this though. C++ metaprogramming.
Metaprogramming is beautiful, honestly. His base of task info, decal type object. Probably want to.
Let's do remove reference or whatever. Decay. Decay T? Okay, yeah.
I believe so, because it gets the type.
Okay.
It's in replacement of this type.
Mm,
Which then, because this is,
yeah,
I
it's
think
like
this is ambiguous, you
yeah.
need to say that this is type name in order to be able to have the namespace resolution operator there, I think.
So I'm gonna just make a quick compile, even though your stuff probably won't, just to see if it already. We have to instantiate this. Do we? No, we don't. This
Instantiate the task list? We do.
No, this is it. It's automatically, obviously, instantiated.
Fine to create a binary semaphore every frame, correct?
Yes.
So, if I understand correctly, we want to be able to provide the user with their own synchronization. But obviously, submit commands needs to have into present needs to have the
Do we want them to have synchronization? Maybe a special kind, but I don't think they should get the normal. Maybe?
What do you mean? Are you asking whether or not we should provide that functionality to the end user? Are we asking whether or not we should provide that functionality to the end user? I don't exactly understand what the
we should auto-sync first and then implement all the extra stuff later. So at first I could say we don't have any exposed sync. Except,
okay.
Of course, maybe timeline semaphores, because they are very, very convenient. Like binary semaphores, I don't think we should ever.
So should then the swap chain be a part of the task resources, or should there be another way of querying the swap chain from the task interface? Or
I guess it's just referenced.
just it's just referenced. Because it does get copied by value into this lambda if we wanted to.
What?
If we wanted to, we could say impl here. .info.
You don't stream on Discord.
Oh, my bad. Can I call you to me? Is that fine? Because I don't think I can have two instances of my camera at the same time. Windows is weird like that.
Oh.
I can pull you.
Yeah. How do I? Yeah.
So I could say this, but this copies.
Oh, this is smart. You just use the task interface itself to do. That's amazing.
Well, I thought that's what I was supposed to do.
Yeah, I think so. Yeah, that's how it should work. Yeah.
But what I'm saying is here I'm copying something. I don't know if it's the swap chain, if it's the impl info, or if it's the impl itself by value here. And
fine.
This is fine. What if I'm
actually,
copying a reference by value? What?
Sus.
Absolutely sus. I don't know if that's why is impl here. We assert on it, and then
yeah, no. In task list, in task interface, the swap chat should be.
Okay, that's what I was wondering.
Yeah, definitely.
How long have we been going? An hour? Oh, because we started at noon. Wow. Okay. So let's continue. Whoa, Patrick highlighting everything.
Okay, I'm back. I just had to do something.
Mm-hmm. So we hold a raw reference to these objects here in the task interface.
Yeah.
Given that the swap chain is optional, what do we do about that?
Make a get swap chain function that
that returns a reference from where? Or should the task interface have a reference to the task info, like create info?
No.
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 Fuck.
I don't know. Is it optional? Yes.
Is it optional? Which also, by the way, means that the info itself and therefore the task ref counts the swap chain, which
okay, actually,
sense.
maybe we should pass it in when we present. Yeah, fuck it. Just pass it in when we present. I think that makes more sense. That clears a lot of API questions, I guess.
Pass it in when we present.
Yeah, as
But
presented.
then you need to make a copy of it within this Lambda, this task.
Yeah, that's fine. That's fine.
That's fine?
Yeah, for sure.
Okay. That makes sense to me then. Okay. Patrick with the deep exhale.
I'll be right back.
All right. Hey everyone, how's it going? Looks like there are just a couple of you in here right now, but that's fine. Hope you're enjoying it so far. I'm just coding away. Vertex buffer. Holy crap, I'm getting lost. Optional swap chain. Name, we need to. Thanks, Rezimian9K. I appreciate it. We just chillin', Brandon says. Wow, it is really delayed. Let me let me see if I can fix that. Glad you guys are enjoying it so far. Looks like I can't change it during the stream. Just Rex? Okay. Cool. Next time I'll see if I can set that delay to be less. So we removed it from the create info. So it's no longer in here. Now add present needs the swap chain, of course. And Patrick, are you here?
Yeah.
Could you try a build real quick? I just want to get rid of these errors. I think it should work. No, it shouldn't actually. Nothing named binary semaphore in Daxa. That's just wrong. Incomplete. So task list needs to include, CPP needs to include impl device. And impl device, I think, doesn't it include like everything? Yeah, so we don't need to do the swap chain either. Does the device include the task list HPP? That's fine because we're in the source file now. Okay. So now it should work. Oh. No program executed. Swap chain. Binding reference of type Daxa swap chain to value of const Daxa swap chain. Drops const qualifier.
Yeah, I'm not sure if taking them in as const reference makes sense.
I don't take it in as const ref. It seems like taking it as value. Currently playing around with the GL. Nice. I don't have too much experience with graphics programming. I mean, I started probably 2 or 3 years ago. But but I find it a lot of fun. And definitely working with Patrick is a lot of fun. I find we worked together really really well. I find your work very inspiring to continue on the journey. Thank you. Yeah, I mean, if I can be inspiring, that's great. I just want to put myself out there and see what people think about what I'm working on. Seems like people are liking it so far. That's no longer necessary because it is not optional for the present command or add present. This looks like we need to copy swap chain manually. Does this make it const or mute? I actually don't know how Lambda captures work off the top of my head, so let's look this up real quick. CPP reference is our friend. So it takes a list of captures. What are captures? Comma, separated list of 0 more. See below. A lambda expression can use a variable without capturing it. If the variable is non-local, that's fine. It can read the value without capturing it if as const non-volatile, integral or enum type has been initialized with a constant.
Oh, we're missing a pragma runs here. Haha. That's why it's dying.
Oof. Using Firefox.
Oh, yeah,
yep, I like Firefox. Sorry, Patrick.
Yeah, a lot of syntax errors cleared up. Nice.
Wow, okay. That's nice to see. Respect. Thank you. Again, still need to know what the heck the default is and how I can specify it to be mutable. Oh, down here, okay. Okay, awesome. The implicit capture of this when the capture default is equals is deprecated since C++20. Interesting. Syntax of an individual capture. Am I dumb? What am I not getting here? Copy capture with initializers pack expression. Oh, 1. Copy by capture. Then it should work. It should copy swap chain by capture. I mean copy. Oh my god. It should capture swap chain by copy. But it failed because it's const for seemingly no reason. Oh my goodness. Because the lambda itself is immutable. So I need to say that the lambda is mute. How does that work? Because by default, this operator, the like operator overload where you call the function itself is a const member function. So mutable is the specifier you use right here. And that should fix that error. Boom. Except for this. What is this? Out of line definition doesn't match. That makes sense.
Ich weiß es nicht. Ich glaube nicht, dass er sich irgendwie hält er sich nicht gut.
Blockchains in there like swimwear.
Yeah, this is getting annoying really fast with the type safety.
You think so?
Because it's just the same code again and again.
Mm-hmm.
I'll be right back. Yeah, this is getting really fast with the type safety.
You think so?
Because it's just the same code again and again.
Mm-hmm. Welcome back, Tasty. Glad we figured out that issue there. This, I don't know what Patrick's trying to do. He's being a little suspicious. Here we have an error. It was because swap chain's not included. That should be fixed. Just a little tired. See if this compiles. It looks like it did. For some reason it defaulted to GDB, but I can launch Mandelbrot. I guess I can't set which sample it is on his machine because, of course, Patrick and I are in a live share, and so this code is actually locally on his machine. So maybe for a minute, while I wait for him to get back, I will go into my local copy of Daxa and we'll take a look at what we have there. So what am I working on right now in Daxa? So we've created a crap ton of samples. Let me just show those off real quick. This is going to be actually the topic of my video tomorrow, or this weekend rather. I will be showing off the work we have gotten done with respect to Daxa and
You tried to launch?
I did. I launched. What the freak? How did yours fail? Mine ran. I ran it.
You just started a like broken configuration, completely different executable.
No, I ran Mandelbrot. I saw Mandelbrot on the screen.
Bruh, for real?
Yeah, like this.
Oh, it works. Yeah, because Mandelbrot doesn't include task list.
Right. Oh, did you press F7?
Mm-hmm.
Build all. Yeah. Okay. So I was just talking to chat. Yo, chatters, what's up? About what my video will be this weekend with, which is about Daxa and showing off all the samples that we've made so that everyone else can go check out how to use it. So we have a bunch of samples like context and device that are just run. They do nothing, but they do create a context and or device. And so if you can run it, then it means that your system is correctly configured to be able to debug Daxa code. So then we also have command list. This one shows off a couple things in the back end in the code. But as you can see, the output is that it sent to the GPU some data and then read it back from another buffer. And I will go into detail on these, obviously, in the video. There's a synchronization sample, which has no output. But then we get to the more interesting ones, like the swap chain, which creates a default swap chain at first, and then closes that window out, completely destroying all of the context with regards to it, and then runs another test, which creates a persistent window, which also clears and shows some usage. We can see that we can resize smoothly. There's no like lagginess about it. We can go ahead and check out the next ones. So task list is obviously the one that we're working on right now. Because task list hasn't been fully implemented yet, it doesn't work. But we have a bunch of other ones. So let's take a look at Mandelbrot. Exciting. I wish I had some pizza right now, Brendan. And you can see, rip, and you can see that the Mandelbrot is going back and forth, and we can resize and everything. It works perfectly fine. Minimization works, doesn't crash the swap chain at all for having a 0 size. And let's just go through these real quick. Oh my goodness. Thank you, Brandon. I'm such a boof. Okay, so let's go back to that. So, goodness gracious, I'm sorry about that. So let's go back to the swap chain one where I said it creates a temporary window. I'm still showing it? Or, oh no, sorry, hang on. Let me check. Let me actually make sure. Let me make sure I'm not an idiot. Issue there. So let's go back to that. So, okay, looks like I'm not an idiot anymore. Okay, so you saw that there was a window created first, and then here we have that smooth swap chain resizing example that I was talking about, where it clears the screen and oh my, what? Ooh, interesting. This is fun. No worries, no worries. Yeah, I'm sorry about the delay. Is this just a fluke or is it I hate things like this because it's not consistent. I did the exact same thing before and it didn't happen. It's within the recreation of the swap chain, but immediately validation gets called. I have no idea why that is. The issue is me using Windows. Yeah, I mean, maybe. I mean, except for the fact that I've tried implementing this on Linux. I've actually done some testing trying to get Linux working for Daxa. Sadly, an even worse issue comes up, which is that resizing at all doesn't work. Big smarty, more like big dummy. No. All right, let's try this again. So we can resize. It's perfectly smooth. Wow, okay. So what the heck's the deal there?
Hello.
Hello, Patrick. I am running into, on my local version of Daxa, a crash after going Windows 0 size. That didn't happen before.
Yeah, but that's application size, I'm pretty sure.
Hey, dotted box guy. That's application size? What do you mean?
Application side.
Right. Oh, yeah. Within the sample, I think, yeah.
Yeah.
Here's the problem. Or maybe, hang on. Yeah. I need to say if size equals 0, that's y equals 0. How did this not happen before? Oh, I didn't test it with specifically the swap chain application. Okay, so that's actually good. This is why we test. So I need to say that the window is minimized when this happens. So I guess, and false otherwise, so I guess we just say this.
Okay, API change. I remove image views. This might be confusing, but you can just put image views into task images from now on.
Okay. Okay, that makes sense. I don't use image views anywhere in the API, by the way, so far.
That's fine, yeah.
Okay. So the reason I was doing the resizing before within the Mandelbrot sample while I was showing it off while it was off screen because I'm a doofus. You can see in this rip dotted box guy. In this sample, we'll see if we scroll down, is that we do exactly what I just put in, and so we need to debug our samples in order to make sure that they all work. And I just found a bug. Might as well put parentheses. I don't really need the parens. So we say resize, and then we want to say if not minimized. Even Discord streams are better. Dang. That's weird. For me, I can load the stream up in 1440p actually. I don't know how it works.
For me, it's high quality too.
Okay. Glad that is the case. Maybe it's the mobile device that you're on. I don't know. But now, what we should see is that if I run this, it actually works as it should. So now we can resize like normal, and if we make it 0 size, it doesn't crash. Okay. So then the next one would be the Mandelbrot sample, which I was. Let's go, Brandon! Pizza time. So obviously the Mandelbrot sample, what this is showing off is everyone has 30 seconds of ping. It's really bad.
30 seconds of but that's
latency,
I think
on YouTube side. and you can see that there is a good amount of frame rate here. And what this is showing off is the ability to do compute rendering, and obviously that's how I render in my game. Is I render everything within a compute shader. But also there are other samples that we have here. So we have Hello Triangle. Hello Triangle is the basic rasterization test. And then another one is Hello Triangle, but in compute. So it uses software rasterization, just like a really simple example in a compute shader of how to quote unquote rasterize, draw the triangle to the screen. Obviously the colors look a little weird, but I just threw it together. How far can you zoom in the Mandelbrot? You cannot zoom in at all. I mean, I can change, so let me show off. If I go into the Mandelbrot sample and we run it, something that's great about Daxa, let me close all these. Hey Logan. Something that's really nice that we can do is we can take, my UPS is mad at me for some reason. Interesting.
Fuck. What is that? Yeah.
It's my UPS.
UPS? You have a UPS?
Yeah, of course I do.
Of course.
Probably shouldn't have two computers plugged into it at the same time. Let me power off my Linux machine for now. See how that helps. I can also turn on VSync in the application so that it's not going 3,000 frames per second and just maxing out my GPU. Probably would be a good idea. What's this? It's a double buffer wait for vblank, I believe. All right, so yeah, let's check this out again, and hopefully UPS doesn't get mad at me. But what I wanted to show off is that is another feature of Daxa, which is that it also has hot reloading. So I can go into the shaders here for Mandelbrot, and I can edit this this compute shader in real time. So what I could do, for example, is change the fact that it's oscillating back and forth. And that's done by adding on a sine of the time. So I can just remove that, and you can see it froze. I can bring it back or remove it again. NVIDIA has built-in VSync anyways in its latest hardware. If you use NVIDIA, you can you can disable VSync within the Vulkan driver so that your application doesn't use it. But what I wanted to show is that I can change where I'm looking. So maybe I want to go down closer to, whoops. I can zoom in by just changing this variable. Hot reloading is awesome. And here you can start to see how my lack of iterations is showing. So if I move up a little bit, or down, I guess, and zoom in a little bit further, I hate this Fortnite map. If I go up, we can see a little bit of imprecision. I think. See here, a few hundred FPS for me. You can change the VSync type in swap chain creation. It is now. Before it was 3000 because I had I had VSync off. Interesting. Found another bug.
Uh-huh.
Don't know what it specifically was, or if we can reproduce it, because it happened when I saved a shader for hot reloading, obviously. Let's see if we can debug
Yeah,
this
that's probably the thing. That's probably VS Code. It does two saves. Once it saves an empty file, and then it saves the.
Oh, do you think
change.
it provided empty data?
Yeah, pretty sure.
Let's see. Cannot call VK destroy pipeline on VK pipeline that is currently in use by a command buffer. Synchronization thing. How can that be true?
Don't they? Are there no pipeline zombies?
Are there no pipeline zombies? I don't know. Let me see.
There are. Do they add themselves to the zombie list? I don't think so.
That is an epic bug that we somehow didn't encounter. If it's true.
Wait. This one enqueues itself. The compute pipeline. Is it a raster pipeline?
No, it's a compute.
Yeah, that should work.
I got off like a good 20 saves before it happened, interestingly. Seemed like it was random.
Oh, do you recreate it while you've already used it? You have to recreate it in the beginning of the frame before you use it in any command list. As soon as you record any commands, it can't be destroyed.
But the command list is still alive, even into the next frame.
Yeah, that's fine.
Okay, so if I do it at the start of the frame, the command list from the previous frame could be still alive.
It can't be destroyed from the point where you used it to submission. After you submitted the command list, it's fine.
Well, I do it at the start of the frame.
That makes no sense. Yeah?
I mean, I could put it in a device wait. A small hack that will fix it, I think, for now. Whoops. Pipeline zombies, is that like steampunk zombies? Am I sure what? That I do it at the start of the frame?
By the way, can't you do a Discord stream over like the normal screen share?
Discord stream of the normal screen share?
Via the normal screen share. You always stream over your camera, your screen, but you can just use the normal screen capture.
In OBS right now, I'm doing just a stream. In when I'm in Discord, if I do my screen, it's what you guys see, what I see. But if I do my camera, then you can see what OBS sees. which is...
Yeah, I don't care. I just want your code.
Oh, you mean, can I share my screen at the same time? Yes, I can.
Yeah.
I should be able to.
Please do.
Screen 1. I'm just destroying my latency. If I my internet, honestly. Ooh, no Code Parade video.
So show me the code.
Here's the code. I just added this wait idle because I assumed that will alleviate all my issues, but it shouldn't be an issue in the first place, obviously.
Make a breakpoint in the... No, that makes no sense.
Anyways, what I was trying to show off before is that there was lack of precision in the Mandelbrot. No freaking way. Max resources. I'm sorry?
From resizing, or?
No, I didn't resize at all.
It just ran?
Yeah, it was while it was just running.
Huh. What resources exhausted?
Let's see.
Cold stack.
How do I know?
Cold stack.
New buffer. It got to 1,000 somehow. Ripped out at box guy. Buffers got to 1,000. I only have... Do I have any buffer? I have one buffer.
Where? Search for create buffer. Okay. Search for create buffer.
Why?
In your file.
Staging buffer. I say destroy deferred. Seems like these command lists never finish somehow then.
Huh. Could be. Interesting. Yeah, that pipeline destroy thing shouldn't be happening still. Even if they never finish, it should just only...
Well, the pipeline destroy didn't
happen at all. I don't know how that could happen. Even if they never finish, the pipeline would just be held forever as a zombie.
Oh, it shouldn't happen anymore though because I have the wait idle.
Well,
this is a separate issue.
I'm reading the cleanup code.
Okay. But I mean, okay, so for viewers, what I was trying to say before, to finally finish my point, with regards to the Mandelbrot detail and zoom, you can get down as far as you want as long as you're willing to give up the performance of having extra iterations to compute whether or not something it is or is not in the set. As you might have seen, I increased the number of iterations to 1,000, and now what we see is more detail. Whereas before it was at 100, and there's not a lot of detail.
I could you try to debug, like see if any resource is like unusually high. I'll be gone on a thinking walk and come back.
Okay. Sounds good
See
to
you
me.
later. Yeah.
He's using 118 megs, which is a lot. Might be validation though, in debug mode as well. Can we get everyone saying I'm a runlet in chat? No. No. Absolutely not. Doing some Daxa debugging. This is what we love. Let's get the error to happen again. And I mean, it's just complete some pill guys in the chat. No. For anyone who's not aware of what they're referring to one of the stickers that we have in the Discord server. You can see it here, pill guy. Oh, I was trying to incur the error again. Can we get it to happen? Let's try to zoom in until it happens again. Pretty. Wide pill. True, very true. Dr. Mario threw those people. YouTube channel emotes are a thing too. I'll have to look into that. I didn't know that. Maybe I can get some emotes for you guys. Let's up the the iteration count again. Ooh. Thoughts on that? That just destroyed the frame rate. Maybe not really noticeable in the video, but even more. We'll get 5 FPS. Look at that. Rundlets don't exist, honestly. And totally my it's even lagging VS Code right now. I mean, we love. I'm a downer. I mean, maybe. How is it not happening? I'm saving all the gosh dang time. You have to be a sub to use the emotes? That's so silly. A sub like a member or a subscriber on just a subscriber, which is free. I'm assuming you mean you have to pay, as in be a member, which is ridiculous if that's true. You're not encouraging. I mean, I'm not encouraging you to be a rundlet that's downer. I mean, I'm also not encouraging you to be like a murderer. Is that downer behavior? I shouldn't debate with. Oh my goodness. What am I doing? Ooh, and we can start to see floating point imprecision. What are your guys' thoughts on this? You like this? Can you see it yet? What do you guys think? Did I make a control Z or something? No. Being a runlet is better than being a murderer. That's an arguable stance, honestly. I love pixels. um, this is way beyond the floating point precision threshold, though. Let's go! I'm sorry, I punched the microphone. I hope that wasn't too loud. Image extent 0 is illegal. Vulkan spec states. How did that happen? It's not freaking possible. We literally just fixed this bug. And that was in another sample. This one should never even run anything related to the swap chain. I'm thinking I might wrap this stream up around 2ish. We'll have to. I mean, I don't know really what I want to keep doing. I have some stuff that I want to do this evening. How do you reproduce it? I don't know. I don't know what happened. I literally don't know how it even happened. It just happened. And also, this is a different thing than what we were having before. The two other times we had a crash, the first one was command list in use. We've fixed that with a hack. The second one was the second one was I don't remember what the second one was, but this one is something with regards to the swap chain being size 0, which should never happen at all. I mean, it just makes no sense, you know? Too many buffers? Oh, yeah, thank you. Thank you. Yes, it was too many buffers, and that didn't happen again. Here we have swap chain is 0. I'm sorry? How? Tell me how. Yeah, this might be a good time to wrap up. I haven't even eaten lunch yet. It's almost 2 p.m. here. I've been working since I got up. So yeah, I think I might wrap up. Oh, there was one other thing that I wanted to show off before I put it in the video for tomorrow. Gabe's being haunted by phantoms. True. Literally true, honestly. But the other thing I wanted to I mean, but this is why we debug. Don't want to put Daxa 1.0 out without having it work. The last sample that I have is this one that is a rasterized voxel renderer, which is really simple in how it works, but I just did it to test a bunch of different things in Daxa. So we have buffer uploading, we have separate buffers. So there's several chunks here, each of which are 32 by 32 by 32. There is separate chunks for water. They are depth tested, so the things behind, which in this case you can't really see, but would be able to see in this instance because this is here. These two are, these things are overlapping, of course. And so it's depth tested. We tested that. We have backface culling. So the inside faces are all not drawn, even between chunks. We have shading. We have I guess that's about it. Let me look at the code real quick just to make sure I've gone over everything that is being tested within this sample. Oh, of course we have. I said it pretty quickly. Buffer uploads, but it does so through a temporary staging buffer whose destruction is deferred. So managing that resource is not necessary manually. So you can see here, I say, oh, rather, it's way up, I think. In update chunk mesh, I think. I go through, I say, so this is, for example, for the water buffer. I create the staging buffer with host access. So we can access its memory from the CPU side, the host. At the correct size, obviously. And then we notify to the command list that this buffer should be destroyed once the command list is done with it. So it'll do that for us. Then what we do is we map the memory of the buffer. We fill it with all of the data we want. So here's that. This is the building of the mesh given the voxel data. And then we just do the pipeline barriers that are necessary in order to upload this. So we wait for our host writing of this buffer to be done, this staging buffer, and say that the next operation can begin when the welcome back, Patrick, can begin when the transfer read access is granted to it. So then that copy happens, and then we wait on that copy and say that the next thing can begin when a vertex shader read is available. So it's just that simple. And the actual buffer itself, the one that is on the GPU, is is persistent. It's just getting written to. And what we do here is we count up the number of faces. And actually, what's interesting in this is these are storage buffers. Waterface and the staging buffer are both storage buffers, and the reason that is because they just hold uints, and there's no vertex layout or attribute bindings, attribute specification at all. And so what that means is that in the vertex shader, what we do is we index into that uint array. We can see here, where is it? Not Mandelbrot. In the vertex shader, nope. In common, we get the vertex invocation ID right here, right? And that's an invocation per vertex. When we dispatch, when we do our draw call, we say that there are X amount of vertices that we want to draw, but there's no vertex buffer. There's just a storage buffer that we then divide that index by 6 in order to convert the data for every uint in the buffer to a collection of 6 vertices, or aka 2 triangles. So in GPU memory, all we actually store is that there's a face at a given position, not any data about the vertex itself. Like triangle vertices, and then we generate those triangle vertices on the fly. So we do we convert a single uint into 6 vertices, which would be huge. So if we were to store this manually, the buffer, if I go in and calculate this, it's 3 plus 3 plus 2 floats, which are all of size 4. It would be, and a uint is also a size 4. So technically, this buffer is 8 times smaller than it otherwise would be if it was a raw vertex buffer, or rather, we did it in the traditional method where you specify each vertex. Never mind, that's one vertex. Sorry, I forgot that it also translates into 6 vertices, so it's 48 times smaller. And that does a lot for saving memory. But it's still so inefficient that just ray tracing into the voxels themselves is way more preferable. And that's why I'm doing it the way I am. All right, I think that wraps up what I have to go over within this stream today. And thank you all for watching.